In the second half of section 5.2, relations and functions, we're going to continue meeting our goals. So on Friday, in previous lesson, our goal was to identify relations and functions. So for the given relation, we had to determine whether a relation, which is set of ordered pairs, was a function or not. So for it to be a function, you have to have exactly one output for every input. So today, what we're going to do is to evaluate functions, and this is your goal for today. So for a given function, I want to evaluate the range and for the given domain. So a couple of vocabulary words I'm going to review is the word evaluate, which means to plug in your input values and simplify using the order of operation PEMDAS. That's what I mean by evaluate. Plug it in and simplify. And next word is a function rule. Function rule is an equation where one input, which is your x, produces exactly one output. Not every equation is a function rule, because not every equation produces exactly one output. But the function rule is when an equation produces exactly one output for every input you plug in. So in example number 3, this says to make a table for this function f of x, which is equal to 0.5 times x plus 1. And we're going to use 1, 2, 3, 4 for our domain values, which is our x. So to make a table, we are going to make x, your domain goes in here, and this part right here, which is 0.5x plus 1, and that should give us our f of x, which is our y value. So you want to replace it with a y, that's fine. So we're going to use 1, 2, 3, 4 our domain, 1, 2, 3, 4. And we're going to replace, so we're going to evaluate. That means to plug it in, so plug in for x, so 0.5 times 1 plus 1. So 0.5 times 1 is 0.5, and 0.5 plus 1 is 1.5. So f of x, when x is 1, is equal to 1.5. And you do it for each x value. So 0.5 times 2 is 1, 1 plus 1 is 2. And then 0.5 times 3 plus 1, 0.53 times 3 is 1.5, and 1.5 plus 1 is 2.5. And then 0.5 times 4 plus 1, 0.5 times 4 is 2, 2 plus 1 is 3. So this is how you make a table given the function rule using the domain 1, 2, 3, 4. So all these numbers you get here are your domain, which are given by 1, 2, 3, 4. And all these numbers right here are your range, which can be written as 1.5, 2, 2.5, and 3. You just list them all if they ask for the domain and range. But this is what I'm looking for as an answer when they ask you to make a table. Now in example number 4, it says evaluate the function rule f of g equals negative 2g plus 4. So this right here has the name of f. So the function rule's name is f that depends on g. So you really don't do anything with this. So to evaluate, remember to plug in these x values. Domain are your x's. These are your x's. Or g's in this case. We plug in the g. And then we're going to find the range. So what this is what you got to do. You plug in when g is negative 1. So what this is saying is when the function with the g is negative 1, so that is equal to negative 2 times g, which is negative 1 plus 4. So what this is saying is when the function with having a g is equal to negative 1, the function is equal to negative 2 times negative 1, which is 2, plus 4, which is 6. So f of negative 1 is equal to 6. So you don't do anything with that negative 1. All it's saying is when g is negative 1, the function is equal to 6. And then you plug in the next one. When g is 3, so when negative 2 times 3 plus 4, so when g is 3, the function has negative 6 negative 2 times 3 is negative 6 plus 4, and negative 6 plus 4 is negative 2. So when g is 3, the function is equal to negative 2. And the last one is when g is 5. So when g is 5, the function is equal to negative 2 times 5 plus 4. Negative 2 times 5 is negative 10 plus 4 is equal to negative 6. So when g is 5, the function is equal to negative 6. So now it says to find the range, so we write our answer like this. The range consists of, and you put in numerical order, negative 6, negative 2, and 6. And this will be your final answer. So you don't do anything with these numbers. All it's saying is when g is negative 1, when g is 3, and when g is 5, the function is equal to those values, which are your range.